Good day everyone, welcome to advanced tutorial class. We are still on differential calculus. We'll be looking at product rule and quotient rule today. Now, what does product rule state? It is a rule for us to be able to solve some given problems in differential calculus. Now, product rule says that the derivative of the product of two functions is equal to the sum of the derivative of the first function, the product of the first function by the second function, and the product of the second function by the first function. We are going to explain that. This is what it says. If we have y and it is equal to a function, and the function has two terms, u and v. Or we call it, this is a function, this is another function. Because it looks like they are multiplying each other, we can use product rule to solve this. Product rule says that the derivative is going to be what? You differentiate the first function, and that will give you u prime, and use it to multiply function v, the second function, and you add it to what? The derivative of the second function, which is v prime. When you differentiate this, you get v prime, and you multiply with function u. That is simply what product rule states. Or if you don't want to write it like this, you can say what? That dy over dx is going to give you the derivative of, v, function v first, which is the second function, is going to multiply what? The derivative of u with respect to x, which is going to be du over dx, right? Then plus the derivative of v, which is v prime, but I'll write function u first, multiplying derivative of v, which is v prime, and that should be dv over dx. So this is simply product rule. Now, we are going to solve this problem. They say we should find the derivative of this function. And if you look closely, it seems that these two functions are multiplying themselves. So we can use product rule to solve them. So I can say solution. I can say let function u be x squared plus 1. I can term this u and I can term this v. I can say v should be 2x minus 6, right? So judging by this formula, I'm going to find the derivative of u prime and the derivative of function v, which is v prime, right? So if I differentiate this using power rule says what? If you have a function y is equal to x, and the derivative is going to be n times the power times x raised to power n minus 1. So I'm going to have 2 times what? 1x raised to power 2 minus 1, which will give me 2x. When you differentiate a constant, you get 0. So this 2x plus 0, I don't need to write it. Now what about this? The power here is power 1, right? 1 times 2 gives me 2. 2 times x is 2x raised to power 1 minus 1. 1 minus 1 is 0. So x raised to power 0 is 1, and 1 times 2 gives me 2. So every other thing is gone. This is a constant, it is gone. So now we can bring in our formula, which says that y prime is u prime v plus v prime u, right? Yes. So u prime is what? 2x. So we have 2x is going to multiply v, function v is 2x minus 6, then plus v prime is 2. 2 is going to multiply u, right? And function u is x squared plus 1. So expanding this, I'll have what? 4x squared minus 2x times minus 6 gives me minus 12x, plus 2 times x squared gives me 2x squared, and 2 times 1 gives me 2, right? So I can call this my dy over dx. But if we look closely, they are like terms, yes? So these and these are like terms, so I can have 6x squared minus 12x plus 2 to be my final answer. Now I want to let you know that you can solve this without product rule. There's another way to go about this problem. I can just simply expand this function. So let me do that on this side. I can expand this function. So x squared times 2x gives me 2x cubed, right? Yes, 2x cubed. X squared times minus 6 gives me minus 6x squared. 1 times 2x gives me 2x, and 1 times minus 6 gives me minus 6. Now I can now differentiate this straight ahead instead of going through using the product rule, but anyone that works for you can do that. So if I'm to differentiate this now, 3 times 2 gives me 6, then 3 minus 1 is 2, so I'm going to have, using the power rule, 6x squared here. 2 times 6 gives me 12, right? So I write my 12x raised to the power 2 minus 1 is 1, so I won't write that, plus 2, the power here is 1, 1 times 2 is 2, I'll write my 2 raised to the power, then I have my x, right, raised to the power 1 minus 1, which is 0, and anything raised to the power 0 is 1, so x has gone. This is a constant, so it's automatically 0. So you see that this is my answer, and this tallies with this, so anyone that works for you can go. Now we'll be moving on to quotient rule, and the quotient rule applies to a function y which is equal to the quotient of two functions u and v. So we could use u and v to represent our two functions, which means that if we have y and it is equal to the quotient of two given functions, then the derivative of y, which is y prime, is going to be the derivative of u times v minus derivative of v times u over what? V squared. This is your quotient rule. It's as simple as that, and you can apply it to solve any given question at all in differential calculus. Or if you don't want to write it like this, you could say what? That dy over dx is going to be v du over dx. This du over dx is the derivative of u minus u dv over dx. This dv over dx is the same thing as v prime over v squared. So now we're going to be using it to find the derivative of this function, 2 minus 3x, and they say it is dividing what? 2 plus x. So solution, we have what? We have that we can rewrite this to be what? 2 minus 3x over 2 plus x, right? Now we can term this to be function u and we can term this to be function v, so that we'll apply our quotient rule and get the answer easily, straight up. So if u is 2 minus 3x, then u prime will be what? The derivative of u, right? With respect to x is going to be what? 2. Derivative of this 2 now is 0. Derivative of minus 3x will be minus 3, right? And then if v is 2 plus x, the derivative of v, which is v prime, or dv over dx, is going to be what? 2 is 0, right? Is a constant. And derivative of x is 1. So we can now apply our quotient rule. So quotient rule says what? U prime. And what is our u prime? Our u prime is minus 3. It's going to multiply function v, right? Function v is 2 plus x. And we'll bring our minus from the formula. And v prime is what? 1. 1 is multiplying u. And function u is 2 minus 3x all over v squared. And function v9 in our case is 2 plus x. So I can write 2 plus x all squared, right? Yes? So let's expand whatever we have up. So expanding, we have what? Minus 3 times 2 gives us minus 6. Minus 3 times x gives us minus 3x. This other side we have minus 1 times 2 is minus 2. And minus 1 times minus 3x gives us positive 3x all over 2 plus x all squared. Right? Yes, so collecting like terms, I can see that minus 6 and this and like terms, and this can go. So I can, the negative 3x has taken the positive 3x because it's 0. So minus 6 minus 2 gives us minus 8. And then we have over 2 plus x all squared. So this is our answer. This is the y over the x. So So that's the simple way you can apply quotient rule to solve problems like this. Now, I have a question for you. I would like you to try it out at your own time. It said using quotient rule that you should find the derivative of 4x minus 1 over x squared. So if you apply this formula, you can get the answer very easily. It is very simple, so try it out. Thank you for watching. Please, if you are new to the channel, remember to subscribe, as it helps with the YouTube algorithm. And see you in the next video. Bye.